Understanding failure analysis. Failure analysis is a systematic process used to determine the causes of failures in engineering systems or components. It aims to identify the root causes of failures, improve design, and prevent recurrence. Conducting effective failure analysis involves a structured approach to investigate and resolve issues. Define the scope and objectives. Start by defining the scope and objectives of the failure analysis. Clearly outline what is being analyzed, the specific failure or issue at hand, and the goals of the analysis. This helps focus the investigation and ensures that relevant aspects of the failure are addressed. Collect data and evidence. Gather all relevant data and evidence related to the failure. This includes documentation, maintenance records, operational conditions, and any physical samples of the failed components. Collecting comprehensive data helps build a complete picture of the failure and provides valuable insights into potential causes. Conduct a preliminary analysis. Perform a preliminary analysis to assess the initial information and identify potential failure modes. This step involves reviewing the data to determine possible causes, evaluating the circumstances under which the failure occurred, and forming initial hypotheses about the failure mechanisms. Perform detailed investigation. Conduct a detailed investigation to test the hypotheses and identify the root causes of the failure. Use various techniques such as visual inspection. Examine the failed components for visible signs of damage or wear. Non-destructive testing, NDT. Employ methods like ultrasonic testing, radiography, or magnetic particle inspection to assess internal conditions without damaging the components. Material analysis. Analyze the material properties of the failed components to detect defects or deviations from specifications. Functional testing. Test the system or components under controlled conditions to replicate the failure and observe its behavior. Analyze data and determine root causes. Analyze the data collected during the investigation to determine the root causes of the failure. Use tools and methods such as failure mode and effects analysis, FMEA, fault tree analysis, FTA, or cause and effect diagrams, Ishikawa diagrams, to systematically evaluate the contributing factors. Identify both direct and indirect causes to understand the complete failure chain. Develop and implement solutions. Based on the root cause analysis, develop solutions to address the identified issues and prevent future failures. This may involve design modifications, changes in materials or processes, or improvements in maintenance practices. Implement these solutions and monitor their effectiveness to ensure that they resolve the problem. Document findings and recommendations. Prepare a detailed report documenting the findings of the failure analysis. Include information on the failure's nature, causes, investigation methods, and the solutions implemented. Provide recommendations for preventing similar failures in the future and share the report with relevant stakeholders. Review and learn from the analysis. Conduct a review of the failure analysis process to evaluate its effectiveness and identify areas for improvement. Learn from the analysis to enhance future failure analysis efforts and improve engineering practices. Share insights and lessons learned with the team to foster a culture of continuous improvement. Ensure compliance and safety. Ensure that the failure analysis complies with relevant industry standards and safety regulations. Adhere to best practices and guidelines to maintain safety and quality in engineering processes. Incorporate any regulatory requirements into the failure analysis and solution development process. Conclusion. Conducting effective failure analysis in engineering involves a systematic approach to investigate and resolve issues. By defining the scope, collecting data, performing detailed investigations, analyzing root causes, and implementing solutions, engineers can address failures and prevent their recurrence. Documenting findings, reviewing the process, and ensuring compliance contribute to ongoing improvements and enhanced safety in engineering practices.